Hello, I am Komal Sharma and this video is about simultaneous linear equations. Now, first of all, what we will learn in this video is what are linear equations, then what do you mean by simultaneous linear equations. Simultaneous linear equations are also known as pair of linear equations, or they are also known as system of equations. It depends on which part of the country you are learning. Likewise, they have a different name. Then we will see how to solve the equations and the methods that are used to solve the equations. Then the methods are mainly graphical and algebraic. Algebraic mein again you have three methods: the method for substitution, elimination and cross multiplication. And after that we will also learn what do we mean by terms consistent and inconsistent when we talk about linear equations. The first thing we need to know is what is a linear equation. Any equation of the form ax plus by plus c is equal to 0 is known as a linear equation. And how many variables are there? X and y are the variables. So it is a linear equation in two variables. How do you decide it is a linear equation? The power of the variables, if you see over here, the power of the variable is 1. So you see it is a linear equation. And what are a, b and c? They are some constants and they are real numbers. And what are the two variables in this case? X and y. And what is the necessary condition? That a should not be equal to 0 and b also should not be equal to 0. Because if a becomes equal to 0, then this becomes a equation in one variable. The same thing happens when b becomes equal to 0. This becomes a linear equation in one variable. So we have to keep in mind, in order to identify a linear equation in two variables, it should be of the form ax plus by plus c is equal to 0. The next thing we need to understand is what do you mean by the solution of a linear equation. When we say solution of a linear equation, what does this mean? So let us have a linear equation ax plus by plus c is equal to 0, and let me say alpha and beta are the solutions. One thing you must notice is that the solution always exists in ordered pairs. Ordered pairs means the x value will be before and the y value will be the after one. So if alpha and beta are the solutions, it means that if we substitute the value of x as alpha and y as beta, then this should satisfy the given equation. Satisfying the given equation means if we work this out and if we work the right hand side out, which in this case is 0, then the left hand side will be equal to the right hand side. So whatever values of x and y that will satisfy this given equation will be known as solutions of the given equation. Let us understand this with the help of an example. So you are given a question: 5x minus 3y is equal to 9 has a solution 3 and 2. Say yes or no. So what will we do? The given equation is, how will you test? So the given equation 5x minus 3y is equal to 9. And what are the solutions that are given? 3 and 2. So what will you do? Substitute x is equal to 3 and y is equal to 2 in the given equation. On substituting, we see that 5 into, instead of x write 3 and instead of y write 2 and is equal to 9. Now work this out. This is 5 3s are 15 minus 6 is equal to 9. 15 minus 6 is 9 is equal to 9. So LHS comes equal to the RHS. Hence we have verified that yes, 3 and 2 is a solution of this equation. If the answer LHS was not equal to the RHS, we will say that this is not a solution of the given equation. So what answer do we mark? 5x minus 3y is equal to 9 has solution 3 and 2. Yes, it has solution 3 and 2. And when it does this, we say that 3 and 2 satisfy the given equation, or we say that 3 and 2 is the solution of a given equation. We already know that the graph of a linear equation is a straight line. It comes out to be a straight line. So can we plot this and see whether this holds good or not, whether this comes out to be a straight line or not? Okay, so let us take for example this equation x plus 2y is equal to 3, and we will try to plot the graph of this. For plotting the graph, it is not very difficult. You need to have how many points? 2 points for plotting any line. So the two easiest points is, first put x is equal to 0 in the given equation. What is the equation? X plus 2y is equal to 3. Put x is equal to 0. 0 plus 2y is equal to 3. So y is equal to 3 upon 2, or it is 1.5. So if you put x is equal to 0, you get y is equal to 1.5. Next, put y is equal to 0. Why am I putting x is equal to 0 and y is equal to 0? Although I can put any value, but x is equal to 0 and y is equal to 0 make the equation very easy to calculate, and it takes very less time also. Now put y is equal to 0, so you get x plus 2 into 0 is equal to 3, or you get x is equal to 3. So 1 point you have got when x is equal to 0, y is equal to 1.5, and the next point you get is when y is equal to 0, x is equal to 3. Now you have got 2 points. Let us see how we plot the graph. For plotting the graph, what do we need? We need a Cartesian plane. You will do it on a graph sheet. We together can do it on plain paper because I don't have a graph sheet right now. So let us plot this. So we will have a Cartesian plane. A Cartesian plane is a two-dimensional plane, and we have these two axes. The horizontal one known as the x-axis and the vertical one known as the y-axis. They are intersecting at the origin or point O. The right hand side part is known as positive x, left hand is negative x, upper is plus y, and lower is minus y. Once I have drawn this Cartesian plane, let me divide it into equal parts. Doing it on the graph paper will be easier. Since I don't have one right now, you can also do it like this. And you do get questions like this in your exam. So you need to do this, practice this very well. Now I put x is equal to 0 and y is equal to 1.5. How to plot this? From here, x is equal to 0 and y is equal to 1.5. 1.5 means this will be the point. Let us say we get this point as A, 0 and 1.5. What about the second point? X is equal to 3 and y is equal to 0. So x is equal to 3. Move 1, 2, 3 units here. And what about y? Y is equal to 0. So you do not have to go either up or down because y is equal to 0 in any case. So you get this as the point. Now you get 2 points. You join them with a straight line, and this will be the graph of the line x plus 2y is equal to 3. This I have done only for one line. You can also do it for more than one line over here. But we just wanted to prove that the graph of a linear equation is a straight line. Always remember, graph of a linear equation will be a straight line. After seeing what a linear equation is, let us talk about simultaneous linear equations. Now if you look into these equations, 3x plus 4y is equal to 6 and 8x plus 5y is equal to 3. They are two equations. They have the same variables, which are in this case x and y. So a system of equations or a pair of equations having the same variable are known as simultaneous linear equations. So these can be treated as simultaneous linear equations, and they can be solved to find the values of the variables x and y. Now how to solve this? The first method we will be talking about is the graphical method. We know that when we plot the graph of a linear equation, it will be a straight line. So let us see what is meant by plotting the graphs of simultaneous linear equations. Simultaneous linear equations means there will be two equations in the same variable and we will have to solve them. So let us say that there are two equations, a1x plus b1y plus c1 is equal to 0. Let me call this line L1, and the second a2x plus b2y plus c2 is equal to 0, and say this is line L2. Now plot the graph. Three cases will be possible when you plot the graph. First case, line L1 supposing say goes like this. Let me say this is L1. Then line L2 may go like this. This is L2, and they will intersect at one point. Let us say this is alpha beta, and this point will be the unique solution, or this will be the point which will satisfy both equations L1 and L2. This is a case of a unique solution where the lines L1 and L2 on being plotted will intersect at a point, and that point will be a unique solution of both these lines. Can you think of the second case? The second case is when the lines L1 and L2 coincide. Coincide means they fall one on the other. So what will be the solution? Every point here will be a solution. So there will be infinitely many solutions, and this is called the case of coincident lines. Lines are coincident. Over here the lines are intersecting at a point, so that point is known as a unique solution. Over here the lines are overlapping each other, they are coincident, so this will have infinitely many solutions. And the third case that is possible is that this is one line L1 say, and this is the other line L2. Where do you see them intersecting? Are they intersecting anywhere? No, not intersecting. So they are parallel in nature, because we know that parallel lines never intersect each other. So they will never intersect each other, and they will have no solution, because solution means they will have to intersect or cut each other. Are they cutting anywhere? No, they are not cutting. So in this case there will be no solution. So whenever we are talking about simultaneous linear equations, we can have three cases. The first is the pair of equations will have a unique solution, and graphically the lines will intersect at one single point. Another possibility is that they will have infinitely many solutions, and if we plot it graphically, then the two lines will be coincident or they will be overlapping. Over here there are infinitely many solutions. And the third case is that the two lines will be parallel to one another, that means they will never ever intersect, so there will be no solution in this case. This should be clearly understood that the lines are consistent when either they have a unique solution. Unique solution means the lines are intersecting. If the lines are intersecting, then they are said to have a unique solution, and they are known as consistent, being consistent. If they coincide one on top of the other, that means they have infinitely many solutions, and such lines are also known as dependent lines. So you can be asked to prove that the lines are dependent and consistent or only consistent. I am repeating, if they have a unique solution, that means the lines are intersecting and they are known as consistent. If they have infinitely many solutions, that means the lines are coincident and they are said to be dependent also. And if they have no solution, means they are parallel lines and they are said to be inconsistent set of equations or inconsistent pair of equations which will not be solvable. Today's video was about an introduction of simultaneous linear equations. In the next video, we will talk about the graphical solution, how to solve simultaneous linear equations graphically. We will see whether the system of given equations is consistent or non-consistent. We have already studied it in this video. So till we meet next, stay tuned.